Okay, let's see. We got a recording. So, I need to... Before we go any further with this code... I don't know, I just put my music up here. Before we go any further with this code, I need to clean it up a bit. And the reason for that is... In our array marching loop, it is... The indentation is, quite out of control in that array marching loop. And we also have to think about organizing our thoughts on how we return the color value from our rendering function, because right now I feel like it's very disjointed and disorganized. So I think we need to take some of maybe the error cases in our render scene stuff, and I think we need to offboard them into a different function just to reduce some clutter, and figure out, like, why are we nested so deep? Is there a way to not nest so deep, right? So obviously one way to not nest so deep is just not to abuse our indentation levels like this. That could be one way. So we got this. So let's think about how we're gonna do that. We could really uglily kind of like shove this logic into, we could just have like a big function that takes all the values we're air checking here. So the distance to the next, and actually distance to next is kind of everything we want, right? Okay, so I'm thinking that we're gonna create another struct, and we're gonna call it C4D and OK, and it's just going to combine this C4D value with the OK value. And the reason for that is we need a way to look at all these different cases, and we need two pieces of data passed back. We need the actual color 4D, but then we also need this OK value. And so if we just pack those two things in some type of joining object, then we can make that happen. So the other question is, if we're going to do that, should be C4D and then OK, or should it be OK and C4D? What would make more sense? Now I already see that we have it in this order here, so that could be an argument for having color 4D first and then the OK value second. Or we could do OK first and then C4D. Let's think about it in terms of general to specific. I would say that the OK value is definitely more general than a color 4D value. So that would be an argument for doing it the other way. Yeah, I think that an OK value first, and then a color 4D value, even though we have it in this order here in this function, this is a different usage, so it's not, right? We're not just going to merge this object into a struct and then pass it to here. We're going to do a little bit more than that. We're still going to call this with these individual parameters, but we're going to try to wrap all this code into another function. So with that, let's go up to like our structs. So we have some structs like way down here somewhere. And in our structs, we could say, I guess we should probably do it in the order that they're created. I don't know. I don't know what makes sense, but let's say OK and C4D, and all it is a container for the OK value and the color 4D value, right? So OK and C4D, right? And we know that OK is a Boolean of some sort. But I don't know what... Okay, well, let's just do what we can. So, let's take a look and see... Do we put some breakpoints here? So, okay, what is that defined as? That is int32? Okay, that's fine. So, I32, and then okay. And then... This is a vec4 and color 4D. Right, so that all it is a container that has these two things in it, right? Okay. So with that, let's figure out how we're gonna make use of this object, right? So in here, we just want to collapse all of this code to where and where are we here? We are... So all these if statements... So all these if statements that we have should probably be if OK is greater than 0, right? We should probably have like a guard for all of that, right? Else so I almost feel like we should do that just seems bad. Let me not do that. Let's oh, you know what? We can do this. If OK not equal to 1, or if I32 1 is not equal to OK, else. And then down here is like a... Down here is just to never execute, but then this part is, do nothing if error state. Do nothing if in an I don't know how to spell erroneous. Let's just do that. Okay, so we're just gonna do nothing if we're in an erroneous state. So we didn't really make many changes there, but the idea is just to kind of like stub something in there, and also make sure as a little sanity check that this is still working how we think it should work. Another thought is yeah, that's fine. I'm gonna put a little to-do list here. To-do, animate the colored cross-section gradients. Might be fun to animate those. And if we're not done figuring stuff out, we gotta like add something to just make it look cool. So we'll add like maybe an animated gradient here. We'll see where we get. Okay, so this stuff here, this is testing distance to next. So we're just gonna say, okay, C4D equals, equals, let's just call it bug001, or, yeah, I really don't care what the name of this is. All we're doing is we're taking this distance to next and air checking it, right? So we're gonna take the OK value and the C4D value, and then the distance to next, right? That's the only thing we're it's the only thing we are testing here, right? Distance to next, right? We use a little type def, but yeah, that's all we're testing. So let's just do distance to next. So dn debug distance to next, and then OK equals this thing right here. We're just unpack it after we call it, right? Dot OK, and then C4D, same thing, equals OK C4D dot C4D, right? Okay, and from there we can create this bug function. So let's make sure we didn't like create anything like this before. Okay, so this bug function is going to be for debugging SDF render scene. So we'll say we'll call it SDF render scene dot bug 001, right? Let's give it kind of like the subsection header so we kind of know exactly where this belongs, right? So SDF render scene dot bug 001. So my strict organization of putting things in first degree functions, second degree functions, etc. is kind of like being thrown out the window a little bit. Or you could say that I'm giving this as, since this is really just a function that's just been extracted for convenience, you know, maybe you could argue that it's still the same degree as this function. Like if you wanted to fly loose with the definition of what degree removed from main our function is, and maybe that's a good way to go with it. So for this, we're going to return a OK C4D object, and it also needs to be all uppercase because that is the struct name. And we're going to take OK, we're going to take C4D, so we're just going to take these parameters in the order, in the same order, just because it's easy that way. And then we can also use dn for distance to next, but let's make it all lowercase since dn distant okay, and okay, so that's good for me. The OK value, the C4D, and the distance next value. So let's look at the actual logic that we're going to extract. And it's just like this bug checking logic, right? Because this bug checking kind of section is kind of distracting from the main code, right? The main logic. So we want to just cut that out and just replace it with this debugging here. So we don't have to think about it when we're looking at the logic. That we only have to think about that when things are actually going wrong, right? So with that, it looks like we can also like save a little bit of space now, right? This is now just distance to next here. And this PC, cos, itime, whatever. Okay, so that's just used to kind of give us some little animation kind of stuff. And that's fine, just giving us a more exact color. And I notice we have a break. Okay, so that's probably pretty important. I'm also noticing we don't have a break here. So let's look at where we extracted that really quick, because that might actually be a bug. We are inside a for loop. Okay, so if we're inside a for loop, we want to exit as soon as possible if something goes wrong. So we're going to say that, you know, if u32, i32 1 not equal to OK, then we're going to break, right? And also we have to kind of declare this OK C4D somewhere. So we can just say okay. So this is kind of bad to like have this we have these variables here, but then we also have this variable, which is a copy of it. We've kind of fractionated our variables, and we're using more memory than we should. So we should probably think about maybe not doing that. But let's solve like one problem at a time, right? And so if OK ends up being not OK after return, right, because we're going to unpack it, then we're going to break out of here. So let's look at that debugging code again. Okay. So yeah, these breaks here, we don't need them anymore because we're just going to break out once now, right? So we can get rid of some of that verbosity, right? And we can also remove some of this indentation here, which might save us some headaches, I think. Because now we have enough room to where we can do that. And dn actually will need to be dn should be, and we can ease up. We can have a little bit more room to breathe now because we're not cluttering up our main logic so much that we can kind of expand this and make it a little bit easier to look at. And we can get rid of some of these colored comments and just use these kind of comments, so that we have kind of this clear distinction where we have, this colored region for the section, and then just everything is not colored over here except for the numbers. So that looks good to me. And now we just need to have a return value. So we're gonna say OK C4D and OK C4D, and really this is just our return container, and we're going to take these two parameters and deal with them. So over here, we actually need a little bit more robustness here. So this is a air color as well. So we can, it's not an official like pixel air color, but it's still an air color. So we need to go OK minus minus here. And same thing over here. This is also an air color. OK minus minus, and then if it's infinity, that's also an error. OK minus minus, right? So now we have this way where we can kind of debug this. Now we could say that we could have a configuration here where this function is empty when it's like some type of debug mode. So we could do we could do like a if SDF debug mode on is greater than or equal to 1, then we could do all of this stuff, right? And otherwise, else, and then end if, and then in here, in this end if, we could actually, no. If we forget to define this or something, we're going to have a mistake. So let's do the, and also we should probably have the less verbose case at the beginning. So if the debug mode is off, else, and if. So by having the less verbose code as the first case, it makes it less likely that you're going to accidentally miss the branches, right? Because if this is like a one-liner of code right here, and we have this block here, if this big block appears first, it's going to increase the likelihood that we're going to miss the small block of code. So if we are not in debug mode, we're just going to say that OK C4D dot OK, and actually no, we won't do anything, right? Because we're gonna return it anyway. So do nothing, right? So we actually don't need anything there, but we do need to pack up the values. So dot OK equals the OK value, and then the C4D value equals the C4D value, like that. Okay, like that. And then we can just return OK C4D, right? So we could align it like that, make it a little bit easier to look at, or it might be worse to look at, depending on your opinion of things. So I do like that. That looks good to me. The next thing is that because it's a define, I like to, when I can, kind of section it off with these little hashtags so that I can kind of tell where those branches for the define are defined, right? Okay, so we're only going to use this object to relay back what the original inputs were, right? So nothing fancy there. And then for this dn, we can refactor the dn to be lowercase dn. And that looks good. I like that. And let's go up into our configuration, and I think we even have a debug section somewhere at the top here. So debugging the color of empty space, and we already have a section. So SDF debug mode, and that is going to be a 1, and we'll use define for that. So define. Excuse me. Okay, so that looks good to me as far as organizing this. Less than or equal to 0, it's not on. And then else, we'll do this stuff. And that's so if we forget to define that, I think it will probably crash on us, but let's say we forget to define it, so this always evaluates to false. If we make any mistake, I want it to be more likely to execute this if we make a mistake and forget to declare this, right? So that's why I did this is less than or equal to 0, because if this is not defined, then it is not less than or equal to 0, because it's not kind of like a comparison to undefined, and a comparison to undefined is always false. Now, I don't know if GLSL shaders work like that, so maybe if we don't have this defined, it'll just blow up in our face. But I just like the way this is written, just because if the worst case happens to this and the code still runs, we're going to end up executing here. And we can see this case easily before this case, because since this case is very small, we want this case first so that we don't accidentally miss it, because we see all this big block of code and we don't see like a little bit of code right at the end, right? Okay, so the reason why we're just calling it bug001 is just to be terse, and also because we really don't give a fuck about what this function name is, because it's kind of this thing where we're just kind of sweeping this code under the rug so that we don't have to look at it, right? And yeah, so that looks good to me. Now we gotta hope that we didn't do anything really stupid and make some type of mistake. Hopefully the only mistakes I've made so far are syntax errors and not some type of fundamental logic error that's gonna make this all blow up in our face, right? So let's take a look, see what I screwed up. Okay, syntax error. Okay, yeah, so I seem to think that GLSL is JavaScript now. So this is obviously wrong because, let's try dead. Let's fix that up a bit. So let's put each of these on a different line, and we know that the first one is like a int32. Let's give it more space. We have room, so might as well give it some space. And int32 of vec4, and the distance to the next, I believe, should be a float32. And now that we have this room, right, since we've added that kind of room, we can take that exact variable name and we can actually put it there, so we know exactly what this is, right? So we're not getting it from the Vox object, right? We're not going to pass in the entire Vox object. That'd be kind of wasteful. But we can at least make a note of this dn value. That's exactly where it is being derived from. Now, if that's the way we're doing it, would it make more sense to make this dn just disnext, right? Because now we're kind of fractionating our variables. There's definitely a good case for that. But then the other case is if I'm control Fing for everywhere I see disnext, I probably want to skip over all this debug code and just go to like exactly where it's being used in a meaningful way, most of the time. So by making it an alias, I can only see it referenced here and know that it is being used in this debug, and then I can skip over it really quickly by just control Fing to the next point where I want meaningful usage of disnext that is not in a error checking context. So, okay, yeah, I think that's good. int32, vec4, and is everything okay? Right, that's what it means. And color 4D, color 4-dimensional, right? And we can make extra notes because we have the extra space, so we might as well take that extra space and use it to just add extra documentation. Even though we've probably have the explanation for what this is in multiple places, it's never a bad idea to re-explain it somewhere else, right? Because we're being this terse. And with that terseness, it does help to give people reminders, right? Okay, yeah, so let's take that and see what we got. And so I don't see any changes so far. Now... So this is if disnext is negative, right? We're gonna do this. So what we're gonna do is we're gonna make sure that this code actually is functioning properly. So we're gonna go over here, and with this distance next value, which is just a define, we're going to quickly debug this really quick. And we're gonna make sure that when distance next equals I32 0 minus 1 I don't know, 44, right? We just want to make temp debug. We want to make sure that when this is an erroneous value, that all of this code yields a result on screen that informs us of the problem, right? We want to make sure, because right now we have this break right here, we want to make sure that all functions properly, right? And because we have already debugged this code, we do not have any, like, bugs in it. Well, I mean, we probably have some bugs somewhere, or, you know, The line between bug and not bug is kind of a gradation, I think, in shader code, just because of the fact of life of having rounding errors. But we don't have any explicit errors that we're checking for in this code right now, right? So we need to introduce an error into this code to make sure that everything kind of like freaks out on us and looks proper. So, and oh, do I have to add that to a constructor? How do I got to do that? Hold on. So, assign cannot convert from const into high p float. Oh yeah, distnext is not a int 32. What am I thinking? That's a float 32, right? Because it's like it has to do with the ray marching, so we need more fine precision. Okay, cool. So we got this like orange color. Now that's helpful. I know where the orange is coming from, but we should so this pulsing orange, right? We really don't want to make an error screen that is a pulsing orange, that is like this interpolation. And the reason we don't want to use an interpolation like that is because we won't be able to sample the screen and find an exact hex color to inform us of like what's going on. So what we're gonna do is we're gonna take this function looks pretty useful. I think what we should do is we should try to create a strobe function that can strobe between two different colors, right? So let's do color 4D equals U32, U32, C2, C, C4D, right? C4D. We could call it strobe. But now we have like this other stuff here. I'm gonna call it, so strobe, and then the parameters it takes. So it's gonna strobe, it's gonna take these values, and it's gonna convert it to a color 4D, right? And if we're going to do that, do we technically need iTime? And the answer to that is no, because the strobe function itself could reference iTime within it, so no need to make the call more verbose than it needs to be, right? So what we could do there now is we can do a U32, 0x, F1, F2, F3, or actually 1F, 2F, 3F maybe, or 2F, 3F, 4F, some type of like, you know, very obvious kind of value here. And we are going to reuse this function to create the strobe function. So this takes R, G, B, and A. So we should be mindful to do that as well. Now the thing is that actually I really don't like it doing that, right? Because we're not actually going to be using the I get why we did that, because U32 converted to color 4D, we want it to have the alpha channel because of the abstraction here. Definitely tells us we definitely need, we're taking all 4 of these bytes, right? A uint32 is 4 bytes, and we're converting it to this color 4D. So it makes sense that this would have RGB and A. But for this, I don't think we should. It's just going to make it harder to search for the hex code. So R, G, and B, we're just going to leave it like that. And oh, the problem with that is now this is RGB, and everything is shifted to the right. It's right shifted. So we don't want any confusion with that. So we might want to just say RGB. Right? RGB, to color 4D. And that way we know that this is RG and B. Right? RGB number 1. And U32, could we do U32 0x, how about 5F, 6F, and 7F, right? So the idea is to make a kind of like a very obvious pattern. So when we color sample it, we're like, that is a very highly coincidental pattern, you know? That'll help us, I think. And you know what? We really don't need to try to, like, let's not clutter ourselves. We're inside of the debug function. Let's keep on giving ourselves room to breathe here, and, you know, use up that vertical space. You know, let's abuse that vertical space. We're inside of a debug function. We've extracted this debug code from the main logic, and so we're kind of free to not worry about how condensed this needs to be, right? So, we could call it strobe, or we could call it flash. I kind of want to call it flash, just because F, L, and A abbreviates a little bit better than strobe. So let's look at strobe synonyms on the internet. Make sure we blink. Okay, yeah, so let's just see what there is, so we can kind of come up with a variable name that is sensible. So blink sodium light, that's that could get me on a let's just look it up on Wikipedia really quick and then forget about it. Sodium vapor. Oh, interesting. So I did not know there was a thing like that. Interesting. So I'm gonna just put that for later reading if I feel like looking at it. Sodium light, and we'll just put this in our reference. Sodium dry, sodium light. And then light, we probably have a kanji for that. Try light kanji or sodium. Now, sometimes I think that, you know, getting on these little rants where, like, I'm losing focus and going off and, like, archiving this piece of information is like, oh god, that's horrible, shouldn't you focus? But I find that with the way I work, I either get a lot done all over the place, or I don't get much done at all in general. So it's kind of like, when all my neurons, I think, you know, this is just a guess, but I'm guessing, like, when all my neurons are kind of lighting up and my brain is actually being productive, some of that energy goes into like little side things that are not really focusing on the point of what we're doing. But I think that that's just the way my brain works, and you know, you could say that maybe I lack self-discipline. I don't know. Look, I just need my brain to get the proper amounts of dopamine so that it gets some type of meaningful work done. And if this is the tax on my brain to make that happen, then so be it, right? Okay, so for this, let's just make an entry, light kanji, and light kanji, right? And so now we'll take this little entry here, so it looks like it also means glow, which might be important. Also means low. If anyone speaks native Japanese and can correct me on any horrible mistakes I'm making, you can do that in the chat. I mean, no one's watching, but, you know, if anybody was, you know. Okay, so that's good there. I think we can also... That SM could become a mistake. Not a mistake, but could become a bone of contention in the future if we don't kind of like make a little tag where we kind of like put the SM in brackets, just because finding that, searching for this exact 2 letters is going to be really difficult from my experience. So let's fix that while we see it. And also P for pearl, like, oh no, it's not. Oh, it looks like maybe we removed that. I don't know. Let's just get rid of that. That's junk. Same thing with this SBM. So SBM and SBM. Okay. Anything else? Extracted date and 2020 1201. Okay, let's go back up to where light kanji is. Okay, so now if we type light, we'll have the option for light kanji or light sodium. And that'll just get us back to this if we ever want to, like, right, because there's a whole chain of cause and effect that gets us to certain pieces of information, and if I feel like I like that chain of cause and effect, then I feel like that I want a way to be able to get back there in the future. So I want to construct an environment where the chain of cause and effect has higher and higher probabilities of leading me towards information that I personally think would be useful. And so that's kind of why I take the time to do this kind of stuff, even though you might think that it's tedious and a waste of time. So, strobe. Yeah, let's see the synonyms. So, blink or flash, BLNI or FLA. Or FLA might work just because .FLA files were used for Macromedia Flash, so it's already an abbreviation that I'm kind of used to, or my brain is used to. So if we look at .FLA, created by Adobe Animate. Is that what, is Adobe Animate like is now the new, like, Flash? Or is that an old thing? Animate was formerly known as Flash, which was originally developed by Macromedia but merged with Adobe in 2005. Flash became Animate in 2016. Okay. So, I used to use Flash all the time, but not anymore. Okay. So yeah, we'll use FLA to stand for flash. And in here, we will call it flash. Call it flash, and do you want to call it like flash like that? And yeah, I think that's good. And then we want to make sure that this function comes after wherever this is declared, right? So we can search in a backwards direction for where that's declared, and then make sure that this function appears below it, right? Because this function is going to use that one. So so I'm actually going to just put it here. And we'll say vec4 flash, right? We'll do U32 RGB, and can we indent? No, we can't. We don't. Well, actually, no, we could do that. Let's try to U32 RGB, U32 so obviously two parameters can't have the exact same name. So these parameters are RGB and RGB, and we'll do R1 and R2, or we could do hex 1 and hex 2. Or color 1 and color 2. Doesn't really matter too much. And okay. And this is going to use this function here. So what we're going to do is let's just look at how we're already doing, like a so let's look at like our air 001, because we already have like the strobing effect. And how are we doing that? So we're just doing mod itime, and that's good enough for me. So let's just steal that and go back to the flash code. Oh wow, we used the word flash a lot. That may or may not be a good thing. So in here, we can do else, and we'll call this with H1, and we'll shift it over 8. Shift it over 8, and then we'll OR it with 0x FF, so that the alpha is 100%, right? Yeah, because this has this last thing is alpha, because it's red, green, blue, alpha. So we definitely need to pack on the alpha channel there. So so C for D equals and then the same thing over here, right? We can do C4D equals this, but instead of H1, it's H2. Potentially we could have like an intermediary variable that's either h1 or h2. Like we could write it this way, or we could write it as maybe it would be easier to say, if we want to like say like U32 RGB a hex color with alpha. Right, we could do like hex color with alpha 100, and we could say, you know, well, no, we don't really want to do that, do we? We're thinking way too hard about this. So U32 hex, and then, you know, hex equals H1. And then over here we could do hex equals H2. And then we have, and the reason for that is then we only have like one piece of code to maintain over here to make sure that it's correct, right? And that could be a good thing, right? So hex and or else H1 or H2. And then over here, right, instead of doing that, we'll just say hex. And, you could name it hex no alpha. And then we have a understanding of that when we call this, we're calling it with it doesn't have an alpha channel, right? This hex no alpha shifted over, right? And so we're gonna append 100% alpha before calling, right? So that's all we're doing. Color 4D. Hex no alpha. Hex no alpha is either the first color or the second color. And, you know, no alpha.
Ow! God damn it!
Okay. Okay. So we're gonna say no alpha channel. Just so that it is, a little bit more apparent or a little bit more obvious, because I definitely make mistakes where when I'm passing around hex values, if it's RGB or RGBA, if you confuse those, sometimes you won't see anything, or you'll get like shifted colors and you'll wonder why the colors don't look correct, and it can be a source of great confusion. And we absolutely don't want that kind of confusion if we're trying to use this to create a debug color that we can find in the source code, right? So with this color 4D set, we can just return the color 4D. And we also need to declare it. I like to declare it at the top so that we see the return value at the bottom of the function as well as the top of the function, and I just think that makes things kind of easy to follow. Return this. And we can also tag both of those with return this so we can kind of see exactly where that is, right? And maybe that's a little bit too verbose, I don't know. But that's good enough for me. So map uint to color 4D. So we're going to kind of put this in the same section. I think, yeah. Yeah, let's just keep it in the same section. So let's, even though this doesn't use any of the same defines, let's kind of streamline the organization here of dash line I2 X64. Let's just streamline the organization of that just because I think it'll look better. So I'm still not using a 64 column limit, so everything's off a little bit there. Yeah, I think I'm going to do it like that, because these are just highly related functions, right? Because this one calls that one, right? And so that, to me, makes sense. Let's think of our logic here for a second. So we have this RGBA value, and we shifted over 8 bits, because there's 8 bits in a byte. And we OR it because we want to tack on bytes. We do not want to mask it. Masking would be with the AND. We want to actually just add the bytes, and if we want to add the bytes, we use an OR. I always get that confused because I think of AND as add. Like, linguistically, I think of it that way, so sometimes I get that confused, so I just want to double check that, make sure that makes sense. And yeah, that looks good. I think I am satisfied with that. So let's look at where it's being called and make sure that we're using it properly. So color, well, first of all, that's not the thing, color 4D. And we're going to take these two values, and yeah, we'll create some flashing, and this is no longer pulsing orange, pulsing something or other, but I don't know what it is anymore. So let's take that, and we know that we need to see some type of strobing effect now, but we don't know exactly what it's going to look like, and that's fine. So let's give that a roll. We made some type of mistake. Let's see what we've messed up now. Hopefully it's just something kind of trivial. Wrong operands. No operation that exists that takes left-hand operation to uint and int. Okay, so that is just GLSL being kind of pedantic. So GLSL is very C-like, but it's not quite C code. Like, most of the time, you can think of it as C code, but not all the time. So, so let's see, hex no alpha is an unsigned 32-bit integer, and so we actually need to take this 32-bit integer, but you know what, we've already done this kind of stuff here. So hold on. Oh yeah, we're extracting. So we already have this define, right? And so we can just, so the code was very related. We decided to put all our defines down here, even though we weren't using them, and guess what? Now we need to use one of them. With this shift, it looks like we also have this U. So it looks like we need to make that just an unsigned cast really quick right there. And now that we have it written like that, I kind of want to use a little bit more space here. Okay, so let's give that a shot. So I think we made the right corrections. Okay, so now we got the strobe. Awesome. So the next part is we need to activate our color picker. And we just want to make sure that when we run our color picker, when we run this color picker, we should be able to get one of the two values that is in the source code, right? So let's, I don't know, the color picker takes kind of a while to start up, so. But yeah, so the hope here is that when we color pick this, we're going to get the exact hex color that is in the shader code. And that's just going to make it a lot easier to debug if we do it that way, right? So, and, oh, there we go. So my color picker. So we're going to do this little eyedropper. And we're just going to eyedrop right here and see, okay, 2F, 3F, 4F, right? So I used kind of just a pattern that when you look at it, you're like, there's an obvious pattern there. That's probably not coincidental, right? So now if we take this, can we copy it? Copy hex code. Okay, let's try to copy hex code, and then let's go into this code, and we'll go Control F, and we'll do 2F, 3F, 4F, etc. Find next, and we find it in only one place. That's excellent. Now let's try to color pick some more and see if we can get that other color. It's flashing. Nope. Let's try to sample it again. I think it's kind of luck of the draw, maybe. Okay, oh, and now we have the other color. So we can copy that hex code, and it's right there, but let's just make sure that we can actually search for it. Yep, and there it is, exactly there. So this exact hex code these exact hex codes only appear in the source code here and here, and because of that, when we see this flashing, we can color sample the screen, and we can figure out exactly where that's coming from, right? So that's good. I like that. And the next thing is, if any of these other cases happen, we want kind of a similar thing, right? We just want to repeat exactly this code. You'll notice that, this already uses the built-in pixel error thing, and that's kind of like we only have 9 of these error things, so we want to be kind of what we call it. Maybe this pix error thing was over-engineered, but it is a generic thing we can use. I don't know, but this isn't broken. Let's not change it. But right here, right, once again, we're interpolating between these colors. There's no way that I can figure out what exact hex color that is, so there's no way for me to Control F search for it. So we want to take this kind of code here, and once again, we're just going to paste, and let's change that around. So we have 7F. How about bad, and I don't know. We could do BAD. We could do that, right? We could do that, right? So just we're trying to make them kind of paired together. So A, B, C, D, E. Yeah. So bad 001 and 100 bad, right? Just so that we have a way to kind of see that, right? And then here we have, what do we have here? Is inf. And we just decided that if it's infinity, we're just using this one hex color. But that was helpful. But the thing is we don't want to. We want something that's more obvious, so we want to use these kind of strobing values just so that we can kind of see them, right? It might be good to actually check what these values look like, just to see that they contrast enough, and that we want to make sure they contrast enough, and that they're not just like some color that looks like, black or something, right? So that is kind of a limeish chartreuse kind of color. So that's fine. Let's try this. And that's a blue. So so this is like a lime, and this is a blue. And then over here, let's try these colors. So this is a black, as far as I'm concerned, from what I can see on my monitor. And the other color is... Oh, hold on. I don't think it likes my 0x's. So this is a... No, yeah, I was gonna say, that doesn't make sense. That would really be a black, right? Okay, so that's a lime again, and then... this is still like a blue color, right? So... I'm sure that the blues are slightly different. But not enough for me to see the difference on my monitor. Like, I visually cannot see the difference on my monitor. But, you know, but a stroke between blue and lime is definitely enough to, like, see what's going on there, right? So that is... Yeah, so that's good. So that is... we've kind of cleaned that up. And it's important to clean things up because if we don't take time to clean things up, our progress will eventually slow to a halt. So by cleaning things up, we have slower progress, but we have more torque. And what I mean by torque is we're slow, but we're steady with the progress we can make. So let's take this and let's paste it in here, make sure that we didn't make any type of syntax errors while we did that. It was pretty trivial, so I don't think we would have. But okay, so we didn't make any mistakes. So let's go into our code again, and let's look for where we're introducing that mistake. So let's remove that mistake now, because we've seen that the code executes. Now, there's still the potential that, you know, not all those error conditions will ever be triggered, or that maybe I'm not properly checking for those error conditions, but that's just a fact of life, really. So when you create like test code or debug functions, you lessen the probability that the bug is in your main code, but the probability kind of gets like one step removed. So now the probability of bugs being in your debug code is the same probability as bugs being in code that has no tests, right? And then if you write tests for your tests, then you once again have kind of like just shifted over those probabilities of where the bugs will be. But you can never completely remove the bugs, which Alan Turing explained with the halting problem, which I don't quite understand the logic for it. I kind of understand that it's kind of like this dependency loop kind of thing, but I don't completely understand it. But Alan Turing was a smart guy, so I'm just gonna believe him, you know. So let's keep on going, I guess. So now that we've added that code, how can we kind of further clean this up, right? So not equal to okay. That's just because we want to avoid problems further down the line here. How can we remove some of this indentation, right?
Okay.
One way is we could... Right, so we have this consistency where we have this section header, we put our defines right up against it, and then we indent the function, right? Do we want to wreck that, or do we want to figure out how to fix this?
Okay, you too, thanks.
I feel like this is nested as deep as it should be. Well, it is, because I did it that way. So... Oh yeah, so this is where we're kind of like color coding based on how far away we are. Uh... Maybe we should think about, well, what data is in this function, and how can we really want to, like, take this inner loop, and we want to, we really want to take this inner loop and, be able to call it, let's see if we can remove this, since we're cleaning stuff up. That should not change anything, but, you know, let's, but we did add that when we were trying to find problems, so let's make sure that that doesn't change anything. And it does not look like it did, which I wouldn't have expected it to, but we want to be careful when we're doing that. Because RWN was already normalized. And we can get rid of this, right? Let's get rid of that junk. And we have this break statement that is going to get out of here. So we need to make sure that if we do try to extract this, that we keep that in mind. So what is all the data, what's all the variables that are inside of here that we will need access to, right? And so that define is actually accessing the voxel. And tile D3D, these are probably, yeah, right. So I almost think we should just take everything. I think we should take everything, and we should yeah, we should just make this, else, right, this loop here, yeah, that's kind of a, yeah, that's kind of ugly. This is gonna take some thought. So what do we need to so XYZ needs to be updated, and the array world normal doesn't. That could change if we want some some type of refraction in like a material, and we want to like bend the normal as it traverses through the scene to get like distortion effects from going through materials. But I think that's a little bit too far ahead for us. Let's. Part of me just wants like take everything, put it in a big box, and just a big like struct, and just be like forget about it, right? Just put everything in some type of Raymarch loop struct, and just be done with it. So this Vox object is updated every loop. Is there anything else that is updated every loop, right? Color 4D is updated every loop. So Vox and this kind of object. So we kind of need this object and we need this object. They're going to be updated every single loop. And so we need to keep this break condition. The has and this val, right? Those are just defines for the voxel object. This pixel thing, it is also in our loop, right? It's also in our loop. Kind of hard to tell because the way we indented it, because we were trying to save space, and that's kind of why we need to fix this. So actually that is in our stuff as well. And what does this use? It uses TZ, so it uses the voxel object as well. Well, this is basically the inner logic. Well, actually, this is outside of the Raymarch loop. Yeah, that's outside of the Raymarch loop because this is our loop right here. Boy, that's a disaster. So I think we should take, so all these defines are still kind of, let's take this and let's put it actually right in here, because I want to use these same defines. And yeah, so let's take it, let's create another thing, and we'll call it render scene March. And the voxel object and the pix object are kind of like created kind of with, so let's go up for a second. Let's look at the the Von object that we created yesterday. Or was that earlier today? So struct Von, okay, so what we're going to do is we're going to say, we're going to go up into the top of the code, and we are going to create something. We're just going to do it in multiple steps here. Is that the only place where I say struct Von? Is that the only place I use it? I don't use it in the actual code? I guess so. So, let's take this struct here, and let's look for the other structs. Von. Okay, and we're also going to create a struct that is specifically to be refactored. And we're not going to give it a good name, we're just going to call it refactor me. Right, and we're going to give it that kind of annoying kind of a name, just so that we know that it's kind of temporary. So I know that we can make the rendering pipeline a little bit more generic, and we can use this kind of like Von object rather than the pix and this Vox object, right? We can refactor it to make it a lot easier to work with. So what we'll do is struct refactor me 001. And we'll just say that rather than have Vox 00 and Pix 00 structs, everything can just use stack address Okay, so we're going to kind of get this rendering first before we try to abstract the code like that. And this is just a note here, and we can go into our notes here and see where is stack address. Didn't we type that before? It looks like we used it, but we didn't make it a route to these other things. So let's go over here and let's take stack address, and stack address. And we'll do sta add, and then stack context, and stack context, right? We'll take those, and same thing, we'll make it so that those result in these here, right? Okay. So this refactor me thing, we're just gonna shove in like everything that we need for what we've been doing, and let's hit Control 0 here, or not Control 0, but Control Alt Shift F2, clear all our breakpoints, and then just go to the places that we need to be looking at right now. So render scene. And in render scene, this is the debug code. So RMT001 stands for Ray Marching Tick. RMT, Ray Marching Tick. Right, so a tick function is just a function I call once per loop iteration, and it's just a way for me to extract the body of a loop into a function, right? And so this object is just going to take a refactor me 001, refactor me 001. And it's just going to take that object, right? And right, so it's a blatant kind of sore thumb kind of thing, but it makes it very obvious that, you know, we want this object to be refactored eventually. So with that, let's think about what needs to go in here. So when we're looking at this loop, which is very hard to even notice where that loop is, some of these things are calculated inside the loop. If they're calculated inside the loop, they can just be moved into the function. So this looks like it has a increment, right? It has an increment to it. So we need to keep that state, the XYZ, same thing. We need to keep that state as well. So I think we need, right, rather than unbundling this thing, we can keep that. And then we need the Vox 000 object, and it looks like we need the OK C4D, and then so we'll do the OK C4D object, and also we have this Pix00 object, and I think these are like all the pieces that we kind of need. So it's kind of bulky, and I kind of like I don't know if that is a bad idea. So let's look up passing around large structs in GLSL shader, right? Like how out of hand can we get here? Is there a better way to do this? So how to pass a big 60+ amount of variables in HLSL pixel shader. So eventually I'm thinking maybe we should think about trying to offboard some of this stuff to a texture eventually. If we're gonna have like a lot of information that texture lookups actually might be slower than just passing a whole bunch of stuff to a function, though. Okay. So we're gonna say that so this stuff here, eventually in to do put into to do replace box 00 and fix 00 with generic stack address and okay. So this is kind of stuff we need. So let's take this and go look at that refactor me. And we're just gonna shove in kind of like all that stuff, right? And the cool thing is from the names, we know what the variable names are because, right, the uppercase and the lowercase are basically the same thing. With exception to, this is not exactly a lowercase, right? It's RWC with capital C and RWN. Then this is OKC4D. And then over here, same things. It's just Vox 000, and this is Pix 000. Also, the more consistent we are with our variable naming, the easier it is to be able to like refactor this type of stuff, right? So I'm good with calling it that, and then in also, do we have a semicolon at the end of that struct? Yes, we do. So we're good. So we're going to take this refactor me, and then we're going to call this stuff, and the SDF render scene probably should be returning something. It's the array marching loop, so it definitely needs to return the vec4. Does it need anything else? Like, is it just, are we just going to persist the state in this, and it's just a container for that loop? Is that all we're doing? And I think the answer to that is yes. Distance to next. Yeah, I think so. So, color 4D, because color 4D is the only thing we really care about here. Well, if we're doing this slice rendering stuff, that's outside of the loop. We're gonna need to get access to the object where that refactor me object. This is a questionable. This is all very questionable what I'm doing here. But if we want to maintain this state for every single iteration, we definitely have to have it pass back the refactor me object. So we gotta put the refactor me as an output as well. And we'll just say return and refactor me, right? And we can make changes to it, and then we'll just return it. And you gotta remember that these are returned on the stack, right? So this is a copy, and then we return a copy, right? So everything is being passed by value here. Okay, sure. So we've kind of we haven't really changed anything, but we want to make sure we don't have any syntax errors before we continue. We've kind of stubbed this stuff in. And what are we forgetting here? Von D3D error. Yeah, because I did not declare that correctly. I just kind of shoved that in and didn't even think about it. But this Von D3D should be a int32. And, while we're here, we could also fix that in our comment code as well, right? So, I32, Von D3D, right? Okay, and then let's actually make a note of this, because I don't think we have a note of this anywhere in here, so let's, Von D3D, if we do it correctly like that, we'll do Von D3D, and just a notification that we typed it correctly. If we do Von D3D or Von D3D, it will do that. And if we do it backwards, D3D Von, D3D Von, and D3D Von, we'll say that's backwards. And we'll say to use the Von D3D. We also want an explanation of what Von D3D means. So Von D3D means, and Von D3D means, and that's not correct. We can make that a typo, since I obviously made that mistake. Let's do Von 3D3 means and Von 3D3 means. Von 3D3. Typo of Von D3D. Okay. And then Von D3D. Okay, and if we type it correctly, we'll say that Von D3D. And what does that mean? It means volume element number n index 3-dimensional. Right? Von Okay. So that's kind of what we got there. Just a little note for me to kind of remember if I want to check the source code, if I forget kind of what this is all about. And also Von, if we type Von, try Von D3D. I'm not sure exactly how the Von object is going to work. We kind of just made it this container for an index, which is kind of like ugly, but that'll do for now. Also, let's just say that all capital, same thing, you know. Okay, so we got that, and so it's going to be like this. It's going to be Von. Von D3D, right? That D3D. Okay. That's good. Good enough. What else? Indent. Okay, so let's check that for mistakes, and then we'll keep on going. Okay, so that looks good. Anything that looks like an obvious mistake? Nope, it still looks like it's consistently the same as it was before. Yeah, so just a lot of housekeeping right now. Nothing really that interesting. But if we don't tackle this now, it's just going to be a lot harder later. Okay, so inside of Refactor Me, we want to kind of like move all of the code into Refactor Me, right? So we want to, like right here, we want to just do this. We want to just say that like, and just say like, so this is kind of what we want to do. We want to say like, we just want to say refactor me equals, right? We just want to recursively kind of use it like that. And then we can just get rid of the ideas that we can get rid of like everything else in here. We can just throw that away, right? So let's just cut and paste and hope for the best, right? Let's just, this is gonna take some time to get right, I think. But yeah, let's just do it. So, I'm gonna take that out of there, that big chunk out of there. And we're gonna just throw it in here. And now that we have that in here, we can, get rid of some of this indenting, right? So now we got a little bit of extra space we can work with, right? And this function is just still kind of ridiculously big. We already have that defined for it, so we could just do Well, let's not worry about that just yet. Let's not worry about cleaning that part up. Let's just worry about how we're gonna get this data into here, pack it and unpack it, right? So this slice render needs like the TZ, TX, and etc. So it looks to me like when we cut and paste, we took the bracket that should have belonged to the closing of the of that ray march loop. Yeah, we did take that, so we need to put that back. And with that said, this bracket, where does this bracket go? Else. So this can actually be this if else, blah blah blah, if else, yeah. So all that is good there. And then in our so yeah, we can just take this like that, and that can be nice and cleaned up. And then when we gotta populate the object, so you know, we're gonna be like really dirty about it for now, and just we're just gonna shove everything in there that we can, and we're not gonna worry about, we're trying to not worry about all this crap, right? We just wanna get it refactored, right? So so this is the ray march loop. And technically that other thing was the ray march tick. But we could name both of them ray march loop just so that we can see where those are connected. So we see we named this ray march loop. So let's give the same labels so that we know kind of where that code came from. And so this is ray march loop, right? And we didn't indent here this section just because we'd like to keep as much of this nice space as we can, right? Yeah, so I'm not gonna indent that anymore. And before we loop into here, we just want to like load it up, right? So we're gonna take refactor me001 dot vox 000 equals vox 000, right? And same thing with pix 000. And there's like two other pieces of data. So we have vox, we have pix, we have the OK and C4D. Color 4D. And we also have these guys here, right? So these are passed in, so we actually don't have to unpack them here. We could a lot of this stuff we can pack so that looks like we're going to actually need that because that's used recursively in the loop. So I kind of regret this name where we use the and between it just because it's visual clutter. But let's not worry too much about the visual clutter aspects. Right now we just need to get this working, right? So we're going to say define R01. We're just going to say refactor me 001, and then we'll do undef here, undef R01, just to reduce some of this clutter so we have a little bit more space. R01, R01.vox.pixel.okc4d. This thing, right? And it looks like we need one more thing here. We need a... this guy looks like it's being updated in that loop, I believe. Like, if we look where this is being called, it looks like we need... Yeah, we need that as well, because we're kind of like updating that distance as we're going. So, we're going to need this variable. Yeah, we're definitely going to need this variable packed into here, right? So, and it's a float 32, so we can add that into the refactor me 001 struct as a float 32. So, float 32 and this guy here, right? So this is XYZ's total distance from TDF RWC, right? Okay. So with that, we need to think about how we're using a lot of this stuff here, right? Like this, like unpacking we're doing here. That's kind of like why are we gonna do that? That's not very useful, right? So So this is just going to be this is going to be pretty stressful. So let's aim at being verbose, and we're gonna have to break this into multiple lines because it's about to get refactor me 001 dot xyz and ray world normal. Or ray world, or hold on, XYZ is like this own variable, isn't it? It's like a XYZ is its own thing, isn't it? If we look at the code here, yeah, XYZ is we take RWC, which is the original value, and XYZ is just a vec3 that's kind of added on there. So we actually need to take this XYZ, and we actually got to throw that into the refactor me thing. And so this is kind of wasteful here, where we really, right, we're not really passing references, so it's not like r01.xyz. But the thing is let's not worry about how wasteful it is for now. Let's just worry about getting it working. So we're gonna have this vec3 xyz, right? Yeah, xyz. Copy of RWN, RW Ray World. So it's a copy of Ray World coordinate. So xyz equals a copy of the Ray World coordinate, right? So just that we know that. And with that, we can kind of get at it, right? So we can do this refactor me.xyz is going to be equal to refactor me 001.xyz plus we're just gonna say RO1. Try to keep this kind of simpler, so this is just gonna get really verbose really quickly. So RO1, and we're just gonna prefix everything with RO1, right? So I don't want my I already have all these defines that are already getting out of hand, so let's not put any more on the top, and let's kind of like just kind of do this. So RO1.dn, we have vox.disnext. So I believe the preprocessor is going to correctly interpret this as vox00, and since we were consistent with our naming, that will still work fine, and everything it'll just work, right? That is still a little bit cluttered. Actually, we don't need this plus 0, 0 anymore. And point normal form, so we can get rid of some of that. Right? So point, and then multiply by this. Equals, we can do a plus equals, right? Let's just do plus equals. Right, so it's in a little accumulator. Okay, so this is kind of nerve-wracking. Let's just keep on going. So, the distance from this, let's just take that code and let's also put it in a little define, right? We're gonna wrap a lot of this in RO1 just because, I don't want any more defines running around that are kind of like way up here. So I will keep on doing this if I need to. And before. So we can make a little bit of note that must call this before. Okay, so this is RO1 plus equal RO1, and then if RO1 max distance is a enumeration, so if it is greater than, we're just going to break, right? And the break statement is kind of like an exit, and can we get out of here where it's like so let's not worry, let's not try to make one exit point right now. Let's just do return originally break. So this was break before we extracted it. Was break before extracted. Okay, so that was a break before we extracted it, and now we're just going to return. And once again, we got to be like really careful here. This is nerve-wracking. Okay, so with... And also we're losing some of our indentation again because of how we're kind of like doing this R01 thing. So let's take all this and let's do define R01 as... we can't just define... What the hell is that? So we gotta actually define it as... Right, we gotta... Okay. And... It's kind of ugly, but, make it very obvious, where we're kind of sectioning things off. So R01, and then max distance is already a define. Distance to next is up here, so that's good. Vox is going to be R01. And this is not undefined anywhere, so we got to do undef. Undef R01. And we need a little space there. Okay. R01.vox equals R01, R01, XYZ, comma, ray world normal. So the XYZ and the ray world normal. Boy, that looks awkward as hell, but let's just keep going. So with this object, it takes the OK and the C4D, and we kind of like pass it back, and we unpack it. So some of this unpacking logic is no longer relevant, where we can, yeah, for this OK and the C4D, we can, for this unpacking, we can actually just keep that OKC4D like that, and we can go R01.OKC4D equals this bug function that takes each one of them, which is kind of like weird, but we're kind of refactoring, so some of this stuff might just end up just ugly. So OKC4D.OK, R01 OKC4D.C4D, and then the distance to the next. And I don't know where we're going to put that, but let's write it like that. And we can put the 2 commas in front of it like that. I really don't know what is good for this, but let's just write it like that for now. So R01.OK4CD, which is returned by this bug 01. Originally, this function was designed to unbundle these parameters and pass them individually. So this is kind of convoluted. But we're going to have some convoluted things as we refactor. We don't want to fix every offense all at once, because if we do that, we're going to make a mistake, and it's going to be horrible, and we're going to be more confused than we already are. So with this, where we're looking for OKs here, these OKs need to be changed to just like that, right? Let's just keep it in the struct like that, and right, we've decided that, you know, we're bundling this OK and the color 4D. For whatever reason, they have become bedfellows. So this break was break before extracted. Let's take this code right here. And this is, we also need a, so let's see, this right here tells us to, we need ro1 dot should break equals 1. I don't know what that should be. Because this was break before, and so same thing with this. Like anywhere where we had break, we need to create a should break variable, and we'll set that to 1, right? And then we need to kind of add that to our refactoring object, right? So this before we enter the loop, we know that should break is equal to u32 0, right? So when we first open up this loop, should break is going to be set to 0. We're not going to break, right? And then we're going to enter here, and inside this loop, right, we need some way to just, instead of max steps, we need some way where we're going to exit this looping, right? So if refactor me 001 dot should break, and that's ugly as hell, so we're gonna take let's just take the whole ro1 thing and let's just put it up here on the up there like that, and we can put that there like that, and we can, if we want to have this kind of more lined up, we could do that. ro1 dot should break, and let's take refactor me 01 like that. SDF render scene RMT 001 with the ro1 value. Since it leaks off the screen, we can kind of do that, right? So they match up with each other. And then if ro1 should break is greater than u32 0, or greater than or equal to u32 1, then we're gonna break. So now we've kind of got that break statement back, right? So we're gonna call this hashtag loop tick function. Okay, so let's make some documentation for what I mean by a loop tick function, right? And then also, I don't think we have should break in our struct yet, but let's one thing at a time. So, so what is a loop tick function? A loop tick function is a function that serves as the body of a loop. I usually use loop tick functions to abstract loop bodies with callbacks. But in the case of this GLSL shader, looptick functions are for reducing visual clutter and making the code easier to follow. The main end of a looptick function is being able to get back, being able to reset our indentation. Which might not be wise, since we are adding more load call with many arguments to more load. However, readability comes first, optimizations come very last. Okay. So just make a note of kind of like what we're doing there and why we're doing it. And then we can go back up to where we did that, and we got this looptick function. We got a little hashtag looptick function. Let's keep that above SDF render scene RMT. Should break. If the RO1 should break, then we will break from this loop, right? So we got this nice loop. That's much cleaner, right? We've offboarded that logic. This is a disaster over here, but you know, one thing at a time. So let's look at where we have should break. I don't think we've defined it in the struct yet, and yeah, we don't have it in the struct yet. So let's go up to where we have the refactor me, and we'll go backwards direction. We'll go all the way up to the top of the here. Wow, we already have it in a lot of places. Are we wrapping around? Yes, we are. I was like, why can't I? Okay, so this struct right here, we should have a U32. We're gonna call it should break. And the reason I'm calling it should break rather than should exit or whatever is that we're gonna name it directly after the functionality that it is replacing, right? Because we offboarded inner loop code to a looptick function, we require a should break flag to maintain the original ability of early exiting our shader remarch loop. Okay, so that is kind of like what that is all about. So this is, I'm gonna say this is a little bit stressful just because we're making a lot of changes, and there's the potential that we're gonna break something, and it's gonna be a pain in the butt to figure out what we broke. So we do want to take our time and just be very careful as we are going about this, because there's no such thing as a trivial refactor. Get that out of your head, if it is in your head. No such thing. So should break, and we'll set return. Right. So this will be one of the functions that has more than one exit point. which I really don't like, but that's something we can fix later, right? Okay, so in here, looks like we have some more kind of stuff. And yeah, so this is a disaster. So let's put this to the correct indentation level. And then let's figure out, well, how are we gonna fix this, right? So first of all, let's rename pics. Anywhere we see pics, let's rename that define to get pics, right? So we already have this, so let's just rename it to get pics. And oh yeah, that's like way off the screen already, isn't it? So get pics d3d. If we look all the way down here, let's rename that to get pics. And that is... yeah, that's just ugly. It's very ugly, but, you know, that's what we have. So let's look at where we do this. So we kind of redefined it because we wanted to, like, not lose track of, like, where we were. Let's get rid of these defines right here. So these two defines, let's get rid of those. And instead of this, we're going to... looks like we might have enough room. We barely have enough room. Well, if we barely have enough room, but we have it, then there's no need to make a define for that, so you can just get rid of the define altogether, because that define was kind of like the thing messing up our code anyways. So this pics000 is needs to be inside of the R01. So define, and we'll do like R01 again. R01, and this will be our refactor me guy again. So refactor me 001, and down here, we have the undef somewhere, right? So we'll also undef the R01 as well. Let's try to do it in the same exact order. So R01 comes next. Undef R01. Okay. And this pic stuff, unfortunately, this is going to be a little bit ugly. So tile d3d is this stuff. Let's just do r01 dot pics, and let's just wrap this in. Let's just do a big define block here, and let's just do define XYZ. So all these like things here, like D3D and all like capitals, if we match the case, it's probably only used like right here, yeah? And then the pics D3D, probably same thing, right? So let's, I think that's we got a little out of hand with this, so let's remove these defines. And then over here, we can remove these 3 defines as well. So these guys, we might want to remember what they are. So let's refactor these. So let's take these and get rid of those. Go over here. So we can get rid of this, and we're gonna say that define this is actually gonna be now equal to oh boy, that's a mouthful. So over here we can define these. So I don't think we can do like, I don't think the defines will work where we can just do, like, R01 like that, because that'll just make that tile D3D will be directly replaced with R01. So we're gonna have to keep it like this, where tile D3D equals this Vox. Let's just do what we can. So xyz equals refactor me001.xyz and define rwn rwn all capitals, and that's going to be rwn, and define, and then we just have those other 2, right? So xy, this becomes xyz, this becomes rwn all capitals, and that's kind of ugly, but I think that works for now. You know what we could try, since we're already here, let's change this refactor me, let's make it a little bit shorter, but let's make it something that's like 7 letters, so 1, 2, 3, 4, 5, 6, 7, right? So refac me. We could call it refac01, right? So refactor me 001 to refac01 like that. And that's 7 letters, so I like doing stuff like that. That means we only have 9 things we can name like that, but let's just do that. Let's refac01. So REFAC, that's 5, 6, 7. So 7 letters. And we're just going to take every place that we've done this, and we're gonna change our mind on what that's called. Then we also need the uppercase, so two uppercase, and then we'll call that refac01 in all capitals, and then we can keep the that needs to be replaced. That needs to be replaced. That is good. I guess we can. We might want to also keep the same label. We want to have two different labels. So refactor me 001, right? So we know what that was originally called. This is ugly, ugly, ugly. But okay. Okay. And now we can go through all this, and we can find where we are, right? So now we got this problem here where all this is wrong now. And that will change again as we refactor the, refactor that. So all this stuff, though. Okay, so that now barely fits, but it fits. So, because we can have this has, and that's fine if we kind of like put the defines straight up there like that. That's fine with me. I'm good with that. And so we'll just throw those right there. And so we're kind of like explicit with what those are now. And now we can undef them. Okay. And this dot exit, we have a RO1, undef RO1, so is that defined up here? Yeah, so that's defined there. So we're good there. We can keep it like that. So this needs to be RO1 dot exit, pic00 dot exit, and this once again should be converted to a, if we ever, wherever we see a break, we need to convert that break to this, right? Should break and a return. So if we ever see break in any of the code, we need should break and a return. So do we have any other place where we have break? So we also have greater than or equal to 1. So this means that this iteration is only going to happen once if we're using slice render. That's fine. And we can look at, we could double click this, make sure there's no other places where the word break is highlighted, besides in these comments here. And that looks good. So this C4D, there's no such thing as the C4D object anymore because now it's the OK C4D.C4D, and it's also inside that. So let's take, let's look for all the references to C4D within this function, and let's change that around. So RO1.OK C4D, and we'll set that equal to so C4D is this hex value. I don't know how we want to indent that. I'm not too worried about it. So over here, outside of map bounds, this is currently commented out. So I would rather not deal with refactoring something that's commented out, but you know, it's not too hard. We just gotta take this, don't we? And that's it. That's all we gotta do, right? Yeah, so maybe we can, yeah, that's fine. And this is actually a member of the R01, right? R01, because we packed it in there. So let's do R01 dot, and then we have XYZ and RWC. And we don't have such a thing as XYZ and RWC anymore. They're actually packed directly into that struct. No, it's not RWN is packed with yeah, so let's look at one thing at a time. So RDWN needs to be looked at, but this is kind of ugly. Where else are we using C4D?
You don't have to stop. I just have to measure you. Sit up.
Why?
Don't ask why.
I'm not gonna wear any other clothes. Don't do this.
Shit. You're bigger than you used to be.
Yeah, I know.
What's your pant size?
I don't know. Just don't make me clothes. I need to lose weight. So please don't do that.
I was gonna make you a onesie like this
I need to
to
lose
match
weight.
Frankie.
Yeah. Need to lose weight, need to get exercise. I don't need more clothes. Definitely do not need more
You
clothes.
really don't want me to.
I'm trying to wear this one thing all week so that I don't have to. I don't want to have more laundry to manage. You know, I want less things to think about, not more. Yeah. But anyways, I gotta think here. So okay, so we got C4D. Let's take this here and paste that there. And this is messy. This is messy. It's like we probably should have like unwrapped the we probably should have unwrapped everything when we shoved it into that refactor container. Like I don't know if this is the best way to approach what we've done, but that's what we have, so let's so that's what we're gonna do, you know. So then this should be R01.C4D. Okay, C4D.C4D equals and that should never execute. We really should give that some type of color that actually is a debug color. So let's look at the flash function. So FLA underscore whatever. Let's find that. So let's I thought it was FLA underscore for flash. Oh no, I named it. I actually gave it the word flash, did I not? Yeah. So this one, we need 2 RGB colors. And it's going to return a color 4D. So that's actually what we want to use for this should never execute. We should say that it's going to be equal to this flash thing. And we're going to do a uint32 0x and give it something where I don't know, 404, and, I don't know, 404, 001 maybe, so, 1, 2, 3, okay, yeah, so RGB. And then we can do U32 0x 404. We can do 1 0 0 right, to make sure it's different, right? We make sure these two colors are different enough. We're gonna make it, we're gonna mirror them, right? We're gonna mirror these numbers so that we get two colors that are more likely to be quite different from each other. So if we look at that hex code and we do like 0x color, and see like what color is that. So it says turtle green, and if we take this color, what do we get, right? We just want two distinct colors that we're gonna notice if they're like flashing. So that is pretty much close to black, so it's gonna like flash this turtle green and black, right? Red, yeah. Cool. Okay, so turtle green. Okay, yeah. So let's look at some of the other problems we have here. So I think we've taken a look at that, and the RWC value is going to need to be RWN and RWC. Where are you? RWN and... Oh, you know, I don't even think we need RWC because it's not, Well, here we are. So, we're gonna take, RWC and RWN dot ray world normal, right? So that is a bit verbose, is it not? Did we have that syntax wrong to begin with? Oh, I guess we did. Point normal form. We have a plus equal. Well, now we have... So we take the normal, and we take dn, and dn is this distance to next. So why don't we just take dn and actually write it how it needs to be. If we do that, though, we have a lot of other places where we have to change that. And it is kind of a verbose thing, so actually I think I just want to keep it as distance to next, and not worry about that for now. So same thing here. So RWC and RWN dot RWN. And we can kind of line up the, and try to line up those parameters so that we can kind of see this lined up with this and that lined up with that. Is it ugly? Yeah, this is kind of ugly. But let's just get everything working first. We can judge it later on its merits of how ugly it is. God, this is just a cluster of ugliness. Okay, so we got this OK value, and that OK value still needs to be kind of like in here like that. So anywhere we're looking at OK, let's make sure that that is fixed. So let's see, OKs. And right, so okay, and Yeah, because it's like we have this like okay, but then we have it like paired with like unrelated data, and that kind of makes it kind of we're highlighting things that are completely unrelated because we kind of like packed them together in these kind of like arbitrary kind of fashions. So it would kind of make more sense to like unnest a lot of that structure we have. But for now, this is the way it is, so let's just keep on going with that. So this Vox thing, so we don't have Vox like that anymore. Right, Vox 00. So that's just going to be the R01 dot Vox to get the Vox 00. And are we inside of a scope that has that define? And it looks like we are, so that's good. For defines XYZ RWN and refac dot this is not RWN, this is let's highlight this. So RWN is actually RWC and RWN dot RWN, right? Because RWN is kind of nested really deeply in there right now. That's ugly, but that's how it is. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I think that is almost ready. So with this render scene, we're trying to pack everything in here, right? We're trying to pack all these things that we need into the R01 object, the refactor object, and that way we can kind of not have to worry about all this stuff, right? We can kind of keep this cluster of ridiculousness, this disorganized cluster of stuff. We can just keep it as it already was, and we don't really have to worry about the maintenance of that. We can just say, you know, we could say that this part is variable setup, right? And actually this is setup. So we could take this and we could kind of label what that is, and we could indent all of this one level so that we know that this section is variable setup. We're now running out of room, so we gotta indent that a bit. Voxels will be thought of as 3D. Voxels are just 3D tile map tiles, right? So, okay, I think that's my food. What time is it? Spent almost 3 hours, so I'm gonna get some food, or actually, I'm gonna stop the stream right now. I'm gonna take a break for some food, and then we'll get back to trying to refactor this, and hopefully we didn't horribly break anything in the process.